వెల్కమ్ బ్యాక్ టు శ్రీకర్ ట్యూషన్స్. శ్రీకర్ ట్యూషన్స్లో మనము ఫిజిక్స్లో ఆల్రెడీ లాంగ్ క్వశ్చన్స్, ఫిజిక్స్ ప్యాటర్న్ కూడా అప్పుడు నేర్చుకున్నాం కదా. సో 3 లాంగ్ క్వశ్చన్స్, ఒక్కొక్కటి 8 మార్క్స్ వస్తుంది. ఈచ్ క్వశ్చన్ హ్యాస్ 8 మార్క్స్. సో టోటల్లీ వీ హ్యావ్ 3 లాంగ్ క్వశ్చన్స్. ఇన్ దట్ వీ హ్యావ్ టు రైట్ 2 లాంగ్ క్వశ్చన్స్. Like in the chemistry also, same. Last section C, it has 3 long questions. In that you have to write only 2 long questions. Each carries 8 marks. Okay. So same process in the chemistry also. From 3 lessons you will get single long questions. Those lessons are electrochemistry and chemical kinetics. From these 2 lessons, 1 long question will be arised. Next one is elements, P block elements. Other one is, last one is organic chemistry. Okay. So in the 3 lessons, first of all we have to take here, I want to explain first chemical kinematics and electrochemistry. In that I want to explain to you some long questions. Let us see. First long question is galvanic cell, sorry. So galvanic cell means, what is the meaning of galvanic cell? Let us see. First long question, what are galvanic cell? Explain the working of galvanic cell with a neat sketch and taking Daniel cell as example. Okay, so let us see here. In the galvanic cell, so what is the, first of all, what is the meaning of galvanic cell? What is the meaning of galvanic cell? Means galvanic cell is a instrument which converts chemical energy direct into electrical energy. As we know, energy converted one form to other form. Okay, so in that process, if that instrument which is converting chemical energy to electrical energy, that instrument is called galvanic cell. Okay, so this is about galvanic cell. So this example is Daniel cell. Here it has, these galvanic cell consist 2 half cells. One is anode half cell and other one is cathode half cell. Okay, in the galvanic cell 2 half cells are here. One is anode half cell, other one is cathode half cell. Okay, anode half cell consists zinc rod. So here we are taking anode as zinc rod. Okay, so which is dipped in zinc sulfate solution, and cathode cell consists copper rod which is dipped in copper sulfate. Okay, which is dipped in. So this is galvanic cell. Okay, so as I told you, galvanic cell is a instrument. So that instrument which is converting chemical energy to electrical energy, that instrument is called galvanic cell. Here this is the galvanic cell. In the galvanic cell we have 2 electrodes, one is anode and other one is cathode. Okay, so anode in the sense plus, cathode in the sense minus. So means plus in the sense it needs electrons, cathode in the sense negative in the sense it has excess electrons. As you know already, in lower classes standard you learned what is anode, what is cathode. That's why here just I am telling briefly. Okay, so this is galvanic cell. Okay, so these are this is behave like a, this is a zinc, it is behave like a anode. Okay, so this is copper, it is behave like a cathode. Okay, this is a salt bridge. Understand? And this solution is zinc sulfate solution. This solution is copper sulfate solution. Okay, so here electricity is passing here. We can detect how electricity is passing or not by using a galvanometer. Okay, this is about galvanic cell. Now cell reactions, let us see. At anode what will happen? At anode what are the reactions are happening? So this zinc zinc, it loses 2 electrons. It become zinc plus. Okay. So loses of electrons, that is nothing but oxidation reaction. Okay. Here zinc, originally this is zinc. When it is lose 2 electrons, it become zinc plus 2. So here electrons are losing. This reaction, what it is. So as we discussed, losing of electrons in the sense oxidation reaction, and here copper is adding. Here copper getting means we are adding 2 electrons to copper. Okay, copper ion, Cu plus 2, copper ion. Okay, so when we add 2 electrons to copper ion, it become copper. Here adding of electrons, this is nothing but reduction reaction. Okay, see here by using of these chemicals, so here electric chemical energy converted as a electric energy. Okay, this is galvanic cell. This is your one of the important long question. So next long question in the chemistry, same lesson from current electricity, electrokinematics. So Kohlmann's law. So this law tells us about that the limiting molar conductivity of an electrolyte. What is the meaning of electrolyte? The substance which we are taking to do the process of electrolysis. Just like in previous reaction, we have taken that zinc sulfate and copper sulfate. That solution is called electrolyte. Okay. So electrolyte is equal to sum of individual contribution of anion and cation of an electrolyte. Means one electrolyte has equal contribution of anions and cations. This information we are getting from this Kohlmann's law. Okay. So what is the Kohlmann's law? The electrolyte lambda molar electrolyte. Here in the electrolyte, here we are taking 2 products. One is A and B. Okay. Equal to lambda A plus lambda B minus. Okay. So this is Kohlmann's law. Once again I am repeating you. The equal contribution of in the electrolyte, the anions molar and the cations molar should be equal contribution in electrolyte. This is the law. So now these laws applications. Okay. So one is calculation of molar conductivity in weak electrolyte. So we can use this law to to calculate weak electrolytes. Okay, and it is used to degree dissociation of weak electrolytes. Okay, in the weak electrolyte we can calculate by using this law. It's a degree, and it is used to dissociation constant of weak electrolytes. Okay, so weak electrolytes constant, how many constants are there? So those also we can calculate by using this law. Mainly this law is used in weak electrolytes. Okay, so this is about Kohlmann's law. So one more important question in this lesson, electrolysis. What is electrolysis? And Faraday's law, Faraday's first law. Let us see here. So first of all, what is the meaning of electrolysis? So electrolysis meaning in the sense the process of decomposition of chemical compound, which is if that is in emulsion state or in the solution state. So which in any state, if any state, the ions passing electricity is known as electrolysis. Means once again I am repeating you, if the substance are in the emulsion state or in the solution state, whatever it is. Okay, so it which is in any state, if through that substance has ions, we know that. So in that substance, if that ions in the electricity passes, if electricity passes through the ions, that is called electrolysis. Okay, so in the emulsion state or in the solution state, so if the substance decomposed as a ions. Okay, so that is called electrolysis. Faraday's first law. Faraday's first law is nothing but the amount of substance deposited. So what I told you, electrolysis means, for example, this is anode. Okay, this is cathode. Okay, so some substance are here. For example, like this, some substance are here. This is anode. This is cathode. Okay, so for example, you can take just now we discussed about that. This is a copper sulfate solution. Okay, so here I am taking solution state. Okay, so here copper sulfate, we can write copper plus 2 SO4 minus 2 sulfate minus 2 ions. Okay, as we know, opposite charges are attracted. Cathode in the sense negative, anode in the sense positive. Okay, these sulfate ions are all are deposited on the anode plate. Okay, so these copper means these positive ions, all positive ions are deposited on the negative plate, means cathode plate. Okay, so this is electrolysis. So here Faraday's first law tells us about that the amount of substance deposited at electrode during the electrolysis process, how much amount of ions are deposited, of course that is on the anode plate or on the cathode plate, whatever it is. So that quantity of current, how much current it will passes through the solution, means if current level increased, the quantity of current level are increased, so the depositing also increased. Okay, that information we are getting from Faraday's first law. Once again I am repeating that. So the amount of substance deposited electrodes on the electrodes during the electrolysis process, that is depends on the, means that is directly proportional to passing of the current. Okay, so the amount ions, the ions depending ions are deposited on the electrolytes, that is depends on the quantity of current. Means if we send more current quantity, if we increase the quantity of current, so the deposit will be increased. Okay, if we decrease, the deposit also will decrease. Means the deposit is directly proportional to the ions deposited on the electrodes, that is directly proportional to the quantity of current. So that is nothing but M is directly proportional to Q. Okay, so M is nothing but mass and Q is nothing but quantity of current. So here as we know, Q equal to so M is directly proportional to Q. Q in the sense quantity of current. Quantity of current. So this is M is directly proportional to Q. This is the Faraday's first law. Proportional, between these two it has proportional symbol. Proportional relation. Proportional in the sense, if mass increased, quantity increased. If quantity increased, mass increased. If one decreased, other one also decreased. And as we know, when we want to remove this proportional symbol, compulsory we need to write and constant to write equal. So that's why here I am taking M equal to E. E is a constant. And Q. Can I take this Q also? Okay. So M equal to EQ. So here, but we know that what is the formula of Q? Q equal to I by T. Sorry. Q equal to I into T. So actually formula is I equal to, I means current. Current equal to Q means potential by time. Okay. So by that Q equal to I into T. Substitute here. Then M equal to, what is that? E into I into T. Okay. Now M equal to. So for example, Okay, therefore M equal to E by 96,500 into I into T. Okay, so we can take time in seconds, we can measure time in seconds, and I means current in amperes. Okay, this is Faraday's first law and electrolysis. This is also one of the important law question. Okay, okay children, I hope you understand this. If you understand, please like, share, subscribe Sekar Tuition YouTube channel.